All right, well, this is lesson 2 of the Manhattan Project. And if you haven't watched lesson 1 yet, you need to go back and do that. You can find that in the lecture section of Teams. This lesson also has an assignment in the assignment section of Teams. You probably saw it post this morning on the general channel. It's a Microsoft Forms that asks you questions about the content that we're going over in this lesson. So again, if you haven't watched lesson 1, go back and watch that one real quick and the Lisa Meitner video, and then jump over to this one so you can get the second set of information for the Manhattan Project. So in our first lesson, we talked about the discovery of nuclear fission and how German physicists had discovered that, and Lisa Meitner and her nephew on Christmas Eve took their information, their paper, their publication, and realized that they were actually carrying out a nuclear fission reaction, and they calculated how much energy could be released from that reaction, and they found it was massive amounts. About 20,000 times more energy than could be released from blowing up conventional weapons, which is significant. We also talked about the role Albert Einstein played, the famous letter that he and Leo Szilard sent to Roosevelt to start the Manhattan Project. And so that's kind of where we ended off. So a couple other key players here. Glenn Seaborg at UC Berkeley, that's University of California, Berkeley. Berkeley was probably the foremost, and probably still is, one of the foremost physics universities in the United States. And so most of the key players in the Manhattan Project came out of UC Berkeley. In fact, the U.S. government actually commissioned the University of California at Berkeley, their lab, their physicists, to actually be the head of the scientific aspect of the Manhattan Project. And so we're going to see a lot of UC Berkeley here. So Glenn Seaborg, he has a element named after him, seaborgium. He discovered plutonium in 1941 at UC Berkeley. Plutonium undergoes fission, and so it was thought that this guy right here might be able to be used to make a bomb as well. So we have uranium-235, and we have plutonium-239. Both of them might be able to be used to make a bomb. So in the Manhattan Project, instead of trying to determine which one was better, they decided, let's just try both at the same time. So consequently, they actually began huge projects. In fact, the construction projects for the Manhattan Projects were the biggest construction projects in the world ever at that time. And so they were constructing at a massive pace, 50,000 construction workers building whole cities, secret cities, for the Manhattan Project. So they actually built 2 cities, one focused on plutonium-239 and one focused on uranium-235. Plutonium production inside a nuclear reactor. A neutron strikes uranium-238, which is the most common form of uranium, and turns it into uranium-239, which then, after about a 23-minute half-life, becomes neptunium-239 through beta decay, which after about a 2.5-day half-life, neptunium-239 becomes plutonium-239, and so this all took place inside reactors, as we've already discussed, which is why we don't want just everybody having nuclear reactors today. Leslie Groves was a general. He was famous for building the Pentagon. He wanted to be a field general, but Roosevelt put him in charge as the military director of the Manhattan Project. So his job was, how do we use the bombs? How do we deliver them? How heavy should they be? Things like that. So all the military aspects of this went under Leslie Groves. He was also in charge of all of the building aspects of the Manhattan Project. J. Robert Oppenheimer was the scientific director of the Manhattan Project. He was a physicist at UC Berkeley. One of the things that people kind of scoffed at is that he dated a woman who was a member of the Communist Party, and so that he got a lot of flack for that, and that was more Cold War era type stuff. But for the most part, he was a brilliant scientific director. He was really good at getting people behind his vision, and so he was the one that actually directed the scientific aspects of the Manhattan Project. Frank Spedding purified uranium metal at Iowa State College. About 2 million tons of uranium was produced in a clapboard building, a very small building known as Little Anki. This building produced basically blocks of uranium or spheres of uranium, one of these, and these were pure metal. These were pure uranium metal, and then that uranium metal was then either used as part of the enrichment process or in nuclear reactors, and we'll talk about those in a little bit. In December 2nd, 1942, Enrico Fermi built the first nuclear reactor. If you guys remember, I passed around a little piece of graphite from that reactor. This was in a squash court. This was underneath the football stadium. So the football stadium had stands that kind of looked like this, and those stands underneath them had space under there. And in this space under here, there was like a ledge like this, and this is where Enrico Fermi sat, and then the actual reactor was built down here, and you guys can kind of see a drawing over here of what that might look like. Essentially, this right here is wood that held the reactor together. These right here were graphite blocks. The graphite blocks looked like this, and they had holes in them like that. And then slugs of uranium from Frank Spedding would go down in these holes. So these cylinders of uranium would go down in these holes, and then there would be another one here, and then another one there, and then another one would stack on top like that. And so it would make a pile of uranium and graphite. And CP stands for critical pile. And critical means there's enough uranium in one place to undergo a nuclear reaction. Now what's interesting here, let's see if I can zoom in here. What's interesting here is that this guy right here, this guy in the middle of the screen right here, he had the control rods, and you can see he's looking up and he's got his hand up on this bar, and he would pull those control rods out by hand. And he had a meter stick, and he would measure how many centimeters he pulled the those control rods out. These guys up on the top up here were known as the fire brigade, and they had buckets of water because they weren't sure how hot this thing was going to get, and if it got too hot they could dump water down in there to cool it off. So they're literally sitting on top of the world's first nuclear reactor. Up from the inside of it over here, there's a wire that goes across the top here. That wire was a neutron detector, and then the equipment over here on the far side, where all the people are standing, that was basically an antiquated neutron detector, and they were able to tell whether or not the nuclear reaction was taking place by how many neutrons were being produced. So this all took place in 1942. This is just information about CP1. It used uranium metal. So usually we use enriched uranium-235, but CP1 used uranium metal from Iowa State. The moderator was graphite, and the control rods were there to absorb neutrons. All right, well, all while this was taking place, the Army Corps of Engineers were building 3 secret cities. And so even before Enrico Fermi produced the first nuclear reaction, they were actually building, and that's this little white building here, a nuclear reactor in Oak Ridge, Tennessee. And that was a research reactor. It was a reactor that was there for them to learn how to make plutonium, how to make the reaction more efficient, things like that. So they built a graphite reactor called X10 right in the middle of this secret city. Now, Oak Ridge, Tennessee was in a valley, and it was kind of spread out. There were 3 main sites at Oak Ridge, and by the time they ended the Manhattan Project, there were about 6 or 7 big sites. And so this is what you see on this screen is just one. On the next screen here, this was another. So these aren't the same place. Even though they're both in Oak Ridge, Tennessee, they're kind of separate at different ends of the valley, if you will. So Oak Ridge, Tennessee was in a big valley right out in the middle of nowhere. They had guard stands and barbed wire and guard dogs, and this was a very secret place. Most of the people who worked there didn't even know what they were doing there. They didn't know it was trying to build nuclear bombs. One of the coolest places there was Y12. Y12 was a magnetic separation plant. It was overseen by E.O. Lawrence. He also has an element named after him, lawrencium. Enrico Fermi has an element named after him. So these are a lot of really, really amazing physicists here. So this magnetic separation was a way to separate uranium-235 from uranium-238. And basically, the way that this worked was through the idea that if uranium-235 being lighter was an ion and 238 being heavier, if you had a magnet, these positive ions, so these were positive ions, they would curve around. So you could actually cause them to bend. Ions would normally, so if this is ions shooting out of this thing, they would normally travel straight. And the 235 and 238, 235 and 238 would all be jumbled together in this straight line. But instead, they had a positive magnet here and a negative magnet there. And so as they shot out, they curved. Well, heavier things curve less than lighter things. So the 235 would follow this outside path, 238 would follow that outside path, and the 235 would follow this inside path. And so here on the other side of this contraption, you basically had 2 slits, so 2 tanks here, and they both had slits in them, and the 238 would go in the right hand one and the 235 would go in the left hand one. And so they would fill this thing up. Down here at the bottom would be uranium tetrachloride, so UCl4, and they would heat it up and it would become a gas, and the gas would rise up out of this pot here, and there would be a beam of electrons shooting across here, which would cause these things to become ions, these uranium tetrachlorides, and then they would shoot out really fast, curve, and we would collect the 235 on this end. And so they'd set this up and let it run for about 4 days. They would refill this, they would take out the 235, use it and purify it to make more or use it to make the bombs, and then the 238 would be then used for other purposes, not to make bombs. So this is what one looked like over here. So on this side of the screen, it looks like a big horseshoe, and these were called colutrons. And so inside them, they had these really strong electromagnets. In fact, they were so strong, if you stood too close and you had something metal on you, you'd get stuck to it. And in fact, they use electromagnets, which is basically a piece of iron wrapped in coil of wire. And copper was so scarce during World War II, they used pure silver from the U.S. Mint, about $1.4 billion in silver from the U.S. Mint. And at the end of the Manhattan Project, they actually took these things apart, uncoiled all the silver, and even swept underneath them to get any dust that might have come off. And they returned all of it to the U.S. Mint and was able to account for 99.9% of the silver that was borrowed to make these things. Now, these were the Calutron buildings here, and when they ran, they used approximately just a little bit more than 12% of all of the electricity in the entire United States during the Manhattan Project. So think about the whole US. These two buildings used 12% of all of the electricity in the United States. So that was one separation technique, and this is what these looked like. Each one of these is a calutron. So the tops of these, this was called a racetrack. And so these buildings that you saw on the previous page were filled with hundreds of racetracks. In fact, there were just about 1,100 calutrons in all by the end of the Manhattan Project, all operating at the same time, each one producing a very small amount of uranium each day, of uranium-235. Gaseous diffusion was also invented at Oak Ridge, Tennessee during the Manhattan Project, and these are the gaseous diffusion buildings down here, and there's a smaller one here. They were built one over there. So these are gaseous diffusion plants, and so the gaseous diffusion that we learned about already was actually carried out at the Manhattan Project at Oak Ridge, Tennessee, and the site was called K25. In fact, this was more effective than the calutrons. So the calutrons actually upped the enrichment a small percentage, and then they sent the uranium-235 over here to be further enriched to make weapons-grade uranium. At the same time, all the way across the country, they built another facility called Hanford. It was in Washington State, and they built a series of these nuclear reactors. So there's one over here, there's one over here. They ended up building about 8 of them, and these nuclear reactors were huge graphite reactors where they produced plutonium. And so what they had is they had a tube of graphite, like a long rectangular shaped piece of graphite with a tube in the middle, and inside of it they would put a long cylinder about 8 inches long, and they'd stack in about 12 of these in each one of these tubes, and these cylinders were were enriched uranium-235, but only about 5%, which means 95% of it was uranium-238. And so that uranium-238 would turn into plutonium-239, and that plutonium-239 was then moved over to this chemical separation plant where it was purified, and then it was shipped to the next secret city. So this was a second secret city that was being built, and in fact they started building these nuclear reactors before Enrico Fermi ever even carried out the first reaction. And that wasn't because they were so sure of themselves, but times were desperate. They had to get these bombs built. The third city was Los Alamos in New Mexico. So if you think of the United States, right? Yeah, there's my United States. You had Oak Ridge, Tennessee, New Mexico, and you had Hanford, Washington, and they were all separated from each other. The uranium was enriched here to make bombs, and the enriched uranium was sent to Oak Ridge. The slightly enriched uranium was sent to Hanford, where they made plutonium to make bombs, and they sent the plutonium to Los Alamos. So everything ended up here at Los Alamos. So Los Alamos is where they built and tested the bombs. So one thing that happened at Los Alamos, Otto Frisch, remember that's Lisa Meitner's nephew who helped her realize there was fission. He carried out a very famous experiment here where he figured out how much uranium and plutonium was needed to make a critical mass. And he called this tickling the tail of the dragon, because if he messed up even the tiniest fraction of an inch, that this pile would have gone critical, and it would have emitted radiation and heat in every direction, and he and the people he was working with, who happened to be standing right next to it, would have been dead in just a matter of minutes. And so he said this was like reaching up and tickling the tail of a dragon right before it turns around and eats you. So that was Otto Frisch. And the last guy we're going to talk about before we talk about in lesson 3, the bombs themselves, was Klaus Fuchs. And Klaus Fuchs was the reason that we have or had the Cold War. He leaked information about our bomb designs to the Russians. He worked on what we're going to learn about as the explosive lenses, which we'll see in our next lesson. But he is the reason that the Russians were able to obtain nuclear weapons many years before they should have, and the reason that we ended up having a Cold War. So that's a breakdown of the Manhattan Project. When we have 3 different locations that we've learned about. We've talked about a lot of people and some of the techniques used to make the fissionable material. So now go over to your assignment and answer those questions in that Microsoft form. Make sure you turn it in. Press turn in when you're done on Teams, and that is it. That assignment, I believe, will be due by midnight on Saturday night. I hope you guys have a great day.